In a survey conducted to see how long Americans keep their cars, 2,000 automobile owners are asked how long they plan to keep their present cars. The result of the survey follows. So you have X represents the number of years they plan on keeping their car, and the number of respondents who gave that as an answer. You're asked to find the probability distribution associated with these data, which most of it is still there. Most of it's done. Um, then you're asked to find what's the probability that a random person from the study plans on plans on keeping their car for less than 5 years, and what's the probability that a random person from the study is going to want to keep their car 3 or more years. Okay, then. So, um, as you can see here, I mean, we have these smaller subsets. Now, when I say less than 5 years here, well, before I even get into that, I do want to figure out what the total number of respondents are. Make sure it is accurate. I mean, it did tell us 2,000, but I want to make sure it is 2,000. It's always good to double check that to be sure that there's no miscommunicated information here. Because I should definitely, if I'm looking at the data itself, I should use whatever I get out of the data. And this does say 2,000. If there was a discrepancy, I would go with what the data is listing, not with how it was summarized in the paragraph. But the first one I'm looking to see what's the probability that the random person is going to be from a group where X is less than 5. Now I have to look at this. I mean, I have one group here. Use my laser pointer. One group here that's less than 5, but these are all less than 5 as well. So it stands to reason that I'm going to be looking at these groups together. And these groups, the way they're defined, I can't be in more than one group. It's one of these smaller groups. I could say less than 5 and make that a subgroup, but that's a subset. It's a grouping of 3 of these. So, I'm just going to total the 60, the 440, and the 360, and I'm going to take that out of 2,000. And that gives me 0.43. So about 43% of the respondents say they plan on keeping their car less than 5 years. What's the probability for 3 or more years? Well, again, 3 or more. I mean, I do have this one here that shows X being more than or equal to 3. But all these other ones are also 3 or more years too. I mean, so any of these categories starting here moving down is going to be something I need to consider for this. And so I would add those together, divided by 2,000, and I would get 0.75. So about a 75% chance that a random person is going to be keeping their car 3 or more years.